All right, let's solve some nonlinear inequalities. In order to solve a nonlinear inequality, you want to get your critical numbers. All right, so here's an example of a nonlinear inequality. X squared minus 5x is less than 6. All right, this is a nonlinear inequality. So the first thing I want to do, though, before I get my critical numbers, is move the 6 to the other side so that we have x squared minus 5x minus 6 is less than 0. All right, this is going to help me get my critical numbers. All right, so the first thing I want to do is get my critical numbers. Now, what are critical numbers? Well, critical numbers are anything that make your function 0 or undefined. So any number which makes the function 0 or undefined. All right, well, a polynomial can't be undefined, but it can be 0. And in order to find out what makes x squared minus 5x minus 6 0, I'm going to factor it. Now, of course, if it doesn't factor, you can use the quadratic formula. But this one factors. And this one's going to be x minus 6 times x plus 1 equals 0. So my critical numbers are going to be 6 and negative 1. All right, so I have my critical numbers. Now I'm going to put those on the number line. Okay, so put the critical numbers on the number line. All right, so here's my number line. And I'm going to put negative 1 and 6 on my number line. Now that divides my number line into 3 sections. So the third thing I'm going to do is test each interval. And I test each interval by picking a number in that interval and putting it into the inequality. Now I can use either the original inequality or this one where I've moved the 6 over. It's actually going to be easier for me to use this one where I've moved the 6 over. But I'm going to take a number from each section, put it in here, and see if it makes it true. If it does, then those numbers are part of my solution set. So when we test each interval, okay, here's my test, I'm going to pick the number negative 2 in this section. I'm going to put negative 2 into x squared minus 5x minus 6. Well, that's going to be negative 2 squared minus 5 times negative 2 minus 6. And all I want to know is that less than 0? Is that negative? If it is, then those numbers are part of my solution set. Well, 4 plus 10 is 14 minus 6. That's a positive number, so no, these do not work. All right, so now let's test a number here. Well, 0 is a good number to use there, so I'm going to put 0 in for my x. And when I put 0 in for x, then I can see that I just have negative 6, and negative 6 is less than 0, so that works. So those numbers are part of my solution set, and then we'll pick 7. And so I have 7 squared minus 5 times 7 minus 6 is less than 0. I'll put 7 in for x. Well, that's 49 minus 35. All right, so that's 14. And then minus 6 is 8. That's a positive. That's a positive number, so that doesn't work. So the only numbers that are part of my solution set are between negative 1 and 6. So my answer is negative 1 to 6. Now, I'm either going to put parentheses or brackets or combination around these two numbers. It all depends on whether or not I can include negative 1 and 6 in my answer. Well, since there is no equal sign associated with this less than, I can't include those numbers. So I just put parentheses, and there's my answer. All right, now let's do another nonlinear inequality. All right, this time we're going to do a rational expression. All right, so we've got x plus 1 over x minus 3 is greater than or equal to 0. Let's do that this time. All right, so the first thing I do is I get my critical numbers. Remember, your critical numbers are any number which makes the function 0 or undefined. Well, with rational expressions, the numerator is what I use to find out what makes the rational expression 0, and the denominator is going to determine what numbers make it undefined. So I set the numerator equal to 0, and I get x equals -1. I set the denominator equal to 0, and I get x equals 3. So -1 and 3 are my critical numbers. Now I will put those on a number line. And that divides my number line into 3 spaces. By the way, every problem is unique. Every problem is different. You don't always have 2 critical numbers. You could have 3 critical numbers. You could have 1 critical number. It really just depends on the expression you're working with. All right, so now I've got my critical numbers on the number line. I test each interval. All right, so let's test the first interval by picking the number -2. And when I put -2 in to this expression, then I have -2 plus 1 over -2 minus 3. And I want to know, is that positive? Well, negative in the numerator, negative in the denominator, negative over negative is a positive, so yes, that is. That works. All right, now, if I put a number in here, let's use 0. We'll see if these numbers work. So 0 plus 1, 0 minus 3. Well, 1 over -3 is a negative number, so no, those numbers do not work. Now let's put 4 in for this interval. All right, when I put 4 in, then I have 4 plus 1 over 4 minus 3. And sure enough, the numerator is positive, the denominator is positive, so the whole thing is positive, and those numbers make my inequality true. So my solution set is going to be -infinity to -1. Now, when I decide whether or not to put parentheses or brackets right here, I have to look at my expression. I do have greater than or equal to, so -1 could be included. As long as it doesn't make the denominator equal to 0, it should be included, and it doesn't. So we'll put a bracket there. Now, union with 3 is the beginning of my other interval, but notice I can't put a 3 in here because it makes the denominator undefined, or the denominator 0. So 3 has a parentheses, and it go to positive infinity. All right, so there's my solution set for this one. Now let me show you one more real quickly. This one is going to have a step that you may not think about. This is another rational expression. X over x plus 2 is less than or equal to 1. Now, just like when we had to move the 6 over, we're going to have to move the 1 over. But we're also going to have to get a common denominator before I can start this process so that I can know what my critical numbers are. When I get a common denominator here, then I have x over x plus 2 minus x plus 2 over x plus 2. And we see that I really have x minus x is 0, and then minus 2. So we really have minus 2 over x plus 2. It's less than or equal to 0. So you see, in this case, we only have one critical number. All right, so my critical number is -2. I'm going to put -2 on the number line. And I only have 2 intervals to think about. So let's test my intervals. I'm going to put -3 in for this interval. So if I put -3 in, now I can either put it in here or into the original, but it's going to be so much easier if I use this expression here. So I'm going to say -2 over -3 plus 2. Is that negative? Well, the numerator's negative, the denominator's negative, so the whole thing's positive, so no, that is not. All right, so let's put 0. 0 is good to use right here. So we'll put 0 in for this interval. Now, -2 over 0 plus 2, is that negative? Well, the numerator's negative, the denominator's positive. And so, yes, the whole thing is negative, so that does work. And so my answer is -2 to positive infinity. Now, can x be -2? Well, it does say less than or equal to, but -2 makes the denominator 0, so no, it can't. And there is my answer.